Welcome back one more time. Physical Science with Mr. Stremecki at North Ardell High School. That's right. All right, now, this is going to be a guided help for the worksheet for Module 11-2. Okay, 11-2. Excuse me. Now, in this particular area, we got into acceleration, but we went vertical. We started talking about acceleration going up and down, which is gravity, right? You know, hopefully you watch the videos and watch some of the example calculations and how to do that, so that this will help you go along a little bit faster. But I'd still like to do a couple of these with you. There are 6 questions on this worksheet. I'd like to do at least 2 of them with you, so that you got a good foundation and know what to look for. All right. Now, you got a ball that's being dropped off the back of the stadium stairs, and it takes 5 seconds for it to reach the ground. Calculate the final velocity of the ball will reach the ground. All right, I'm very visual. I'm going to draw me a ball. Ta-da! And it's going to drop right down there. Now, it takes 5 seconds for it to drop. And that's all they tell us. And what they want to know is, when this thing comes all the way down after 5 seconds, what is the velocity of the ball going to be after 5 seconds? Right down there, how fast is it going to be going? Well, what else do we know? Well, when you first had a hand on the ball up there, and you're holding on to it, and you got ready to drop it, what was the initial velocity? If you go back to those instruction videos, we talked about that. That velocity, when you first let go, is going to start off from 0. And starting, speaking of the word starting, that means that's my initial velocity. I'm going to put a little VI there, which means this velocity down here after 5 seconds, is going to be my final velocity. Now, we need one more thing. What is the acceleration of a falling ball? Well, this problem probably occurs on Earth, so we're talking about the acceleration here is actually going to be gravity, right? Gravity, which is, remember, negative 9.8 meters per second per second. Now we got enough numbers to do a calculation. And since we're dealing with acceleration, we're going to be using A is equal to VF minus VI divided by T again. But remember, the only change, since we're talking about vertical, we already know the acceleration. It's going to be gravity, right? Gravity. So, where the G is, let me set this up here. Where the G is, we're going to put in negative 9.8. Where the final velocity goes right there, that's what they want us to find. So I don't know what that is. I'm going to leave VF right there. And over here goes the initial velocity, which is 0. And the time goes down here, which is 5 seconds. Now, let's simplify this thing a little bit. Negative 9.8 is equal to VF minus 0 is just VF, right? And then we're still divided by 5. So let me rewrite that up here. Negative 9.8 is equal to VF divided by 5. Now, to get rid of that 5 down there, you got to do just the opposite, because you want to get VF by itself. So the opposite of divide by 5 is to multiply by 5. Whenever you do to one side, you got to do it to the other side. That way you got one on the bottom, one on the top. They cancel out. So the final velocity is going to be 5 times negative 9.8. Now be careful. There's so many people, they don't go through the trouble of putting a little multiply sign in there. And after they put the 5 over here, they go back and they look at this, and it looks like 5 minus 9.8. Remember, there's a multiply. We had to multiply that 5 over there. So be very, very careful when you got negative signs. It's easy to mix up and get some minus. You're subtracting. So 5 times 9.8. Get our handy dandy calculator. 5 times negative 9.8 is, whoop, that's not the right answer. 5 times negative 9.8, I divided. That's why that was so small. Is negative 49. So negative 49. And what's the units for velocity? We should know that by now. Meters per second. Okay? Now, that negative, a lot of people don't like a negative. Remember, you're my student. You're not going to sweat this. What does negative tell you? In physics, what does negative tell you? Positive, negative always tells you direction, right? Okay, so we're not going to sweat this. That just means direction. And which way is direction? Negative means it's going to be going down, which makes sense. Come back to our drawing over here. Which way was that ball going when we found that velocity? It was going down, which is the negative direction. So we're good. We're cool. We're groovy. Okay? Looks like number 2 is the exact same way. Got a squirrel here dropping an acorn. Number 3, got a helicopter hovering above a boat. Same type of thing. You're just hovering up there. You drop the supply inflatable raft. 9 seconds later, it reaches the water. The exact same way you're going to do this one right here. Let's take a look at number 4. You've got a child playing in the backyard. Playing catch. The ball is thrown straight up into the air and then catching it. And then catching it probably on the way down, right? If the ball is thrown up with initial velocity of 4, calculate the amount of time it will take for the ball to reach that. Ooh, we better do this one. This is a little bit different. All right, first we're going to draw a picture. This one, the ball starts down here. The child throws the ball, goes, comes way up here into the top. And then, of course, after it stops, right? You've all done this. It's going to make its way back down again. Right? No big deal. We all know this one, right? It goes up and then it comes down. Now this point right up here, here's some important things to know. First of all, in physics we refer to that as the apex. Apex means that's the top. It's the top of the line, man. If you're an apex predator, that means you are the top predator in the area, okay? So, the ball's going to go, gets thrown up into the air, and then when it reaches the apex, what exactly is the ball doing? When you think about it, you've done this 1,000 times. You take a ball, you throw it in the air, it goes up initially nice and fast, and it slows down, then eventually it stops. Just for a quick instant, it stops, and then it makes its way back down again with the negative velocity. So this velocity right here is 0. Okay, it goes up, stops with 0, and then it starts to come back down, speeds back up again in the negative direction. What else do we know? Gravity. Nobody turned gravity off yet. Gravity's still over here pulling on that ball. Negative 9.8 meters per second. And when does gravity begin to pull on this ball? It never stops, right? You threw that ball up in the air, gravity was pulling on it down this way, gravity was pulling down, and that's what made that ball slow down until eventually made it stop, and then gravity kept on pulling on it, and it makes it re-accelerate back down this direction. Okay? So, and then the velocity down here that the person threw it, so as the child threw the ball throwing straight up in the air, that the ball is thrown up with an initial velocity of 40 meters per second. So down here, this is 40 meters per second. And they want to know what is the velocity up here. So they initially threw the ball at 40, so I'll put a little I there. If we go up to this point up here and call that final, okay? And they want to know, calculate the amount of time it will take when the ball reaches the highest point. So they're looking for t. So here's our formula. Acceleration is equal to final velocity minus initial velocity divided by the time. And because this is gravity, we're going to turn A into G. Now, you got the G there, which is going to be negative 9.8 right there. Final velocity, we're going from here up to here. So the final velocity up there is 0. minus the initial velocity. That little kid chucked it up there at 40 meters per second. And then the amount of time it takes down here, they didn't tell us. That's what we gotta find. So we'll put the t down there. Now let's simplify. Negative 9.8. What is 0 minus 40? And that's right, negative 40. Not 40. Remember, it's negative 40. And then we got t down there. And once again, we're trying to find something in the denominator. So what do we gotta do? We've only done this about 50 times so far. You gotta cross, multiply, divide. That's right, you got to cross, multiply, divide. Alright, so on this side over here, you're gonna put that over 1. And now you're gonna cross multiply. So t crossing up times negative 9.8. You're gonna get negative 9.8 t. And then crossing up this way, you get 1 times negative 40 is negative 40. Now the divide part. Gotta get that t by itself. So we gotta divide by negative 9.8. Divide by negative 9.8. That way negative 9.8, negative 9.8, they cancel. So t is going to be equal to negative 40. Warm this thing up. Negative 40 divided by negative 9.8. And we get a positive 4.08. And time comes in seconds. Okay? Now, good rule of thumb. Here's a couple things in physics that if you ever get a negative answer, that means we set something up wrong, and you really should double check. And one of those is right here, time. That's why I was trying to be so careful about carrying that negative number in there while I was doing those calculations, because if I wouldn't have, and this came out to be negative, there is no such thing as negative time. Okay? Another thing that can never be negative is mass. Okay, so mass cannot be negative. Alright, let's take a look at number 5. Ooh, this is a fun one. You got a fireworks shell. It's shot straight up in the air with initial velocity. How much time will it take to reach its highest point? They're asking the exact same question here, but instead of a ball, it's a fireworks. It's shot off the ground at 100 meters per second. It goes all the way up to its apex, and that's where it explodes. The final velocity of the air, of course, is 0. So they want to know how much time it's going to take. And for those of you big time into fireworks, the reason why you want to know that time is because you're what's called a delay fuse. Your delay fuse is what causes the explosion on the inside of the fireworks shell. When you launch that, the shell goes up, and when it reaches its apex, that's when you want it to explode. And the inside timing fuse will determine when that explodes. And then number 6, a piece of wood is dropped accidentally from the 3rd floor. How much time will it take? So this one's just like the ones on the front. How much time will it take for the board to fall and hit the ground? Okay? Alright, if you got any questions, shoot me an email or zoom in. Talk to you later.